All right, we're back with example 2. Now, example 2 is all about graphing inequalities. So let's look at this particular example. It says an inequality like 3 plus x is less than 9 has too many solutions to list. You can use a graph on a number line to show all the solutions. And so this is a graph of the answers to this inequality. Now let's see how they came up with this. So first, I'm just going to rewrite this. And remember, whenever you want to figure out what the solution is you have to isolate the variable, right? And this is kind of, inequalities are very similar to equations, right? You just have to, the only difference is if you multiply or divide by a negative number, you have to flip the sign. Otherwise, it's just the same. So if this was an equation and there's an equal sign, what would we do first to get this x by itself? If you said subtract 3 to both sides, you would be correct. We're going to do the inverse operation of 3. That 3 is positive, so we do negative. It cancels here. We have x is less than 9 take away 3, which is 6. So the solution set is x is less than 6. And really all the numbers. So all the numbers that are less than 6, 5, 4, 3, 2, 1, and all the decimals and fractions too, like 2.5 is less than 6, really everything. And this is how you would write that. Now let's go over a few of the things we see here. So if you notice, this is a, like x is less than, so this is a, like the less than sign. So whenever you have a greater than or a less than sign in your graphing, what you do is you use what's an open circle, like that, okay? So notice this is x is less than 6. So they used an open circle. This open circle just means, like, you see how there's like a space on 6? It means it doesn't include 6. So it's everything below 6, but it doesn't include 6, right? Because it's not x is less than or equal to 6. It's just x is less than 6. So it's not 6. It's just everything less than 6. So we use this open circle. Okay, so then the question is, okay, so if we know that greater than or less than, we use an open circle, well, what do we use when we have a less than or equal to? And for that, what we do is we use a closed circle whenever we graph. And this is like seriously like one of my favorite things to do is talk about graphing inequalities, because I just love it, because whenever you have like greater than or less than and you remember that it's an open circle, it's like I just feel like when I look at this, it could just be a super cute like inequality emoji. Like, do you see it? And I don't know, maybe like, I don't know, some like little hair or something. I don't know, just something. But I don't know, it just, every time I see it, I just see a little, you know, cute. Maybe this is like a baby. We'll give him like one like really cute. It's just a baby inequality emoji. And like this one, it's like the same thing, but I don't know. This one just seems like it's a little bit more dramatic, you know. Maybe I'll give him like a little mohawk or something. Oh man, now it just looks kind of like a pumpkin. But yeah. So those are my favorite things, my little inequality emojis. But yeah, so hopefully that will help. So let's go ahead and look at these ones down here. Oh wait, my bad. So yeah, so when we're here, we know that it's less than, so we would do that open, and then it's everything that is below 6, and so all the numbers that are below 6 are this way. That's why there's those dark lines, and it just goes on forever and ever this way. And you just have to make a nice little number line. This one, the number line is in 2s, and that's okay. You know, you can be in 2s or 1s. You'll see all different types of things. So, okay, let's look at some other different examples before we get started. So this one says we're going to do a graph of x is less than 5. right? So we are going to use, that's less than, so we're going to use that open circle right on 5. And if you see that, right here on 5, there is an open circle. It's a little hard to see. I'm going to go ahead and make it a little darker, but it does not include 5, right? So it's less than. We have a number line here, and this is 5. And then it's all the numbers that are less than 5, and all those numbers are this way, right? This way would be all the numbers that are greater than 5. So this basically just means any number over here is a solution. So this is a solution, 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 solution. Anything over here, not a solution, not a solution, not a solution. Okay? So this is all real numbers. Oh, those are the type of words. I need to highlight that. So you say this, all real numbers less than 5. Maybe I should have said that on the previous examples. I'm going to go back to that really quick. So like this, I probably should have said, like the answer, instead of x is greater than or equal to 10, I probably should have said all real numbers greater than or equal to 10. So let's just go ahead and make that adjustment here. All real numbers greater than or equal to 10. Okay, I feel so mathematically fancy. That's the mathematical technical way. So let's just make sure we do that, make that adjustment. And then we can go down here and do the same thing. So for this one, our answer, instead of P is greater than 4, we'll say P represents all real numbers. And there's this really cool symbol you can use for all real numbers. It just, it's like an R, but it has 2 lines like that, and then you just make that, right? That just means all real numbers. So you can put all, this means real numbers, greater, all real numbers greater than 4. So yeah, I'm okay with you writing out all real numbers greater than 4 or using this symbol, all real numbers greater than 4. Boom. Okay, back to what we were doing. Sorry for that little detour. I just felt like we should rewrite that. Okay, let's look at the next one. The next one says all real numbers greater than -1. So here, whenever you're graphing that, okay, it looks like this visually. All real numbers greater than -1. So you're going to make a number line. You're going to find your number 1, right? This is the cute open circle emoji. So you're going to have a open circle right on -1. I'm going to go ahead and make that a little bit more obvious. Okay, and then x is greater than -1. So the solutions are going to be everything that's greater. So this way, everything would be less than. This way, everything's greater. Those are the solutions. So solution, 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 solution. Anything over here, not a solution, not a solution, not a solution. Okay? All right, cool. Let's move on to the next one. So the next one is this. And you would say this, x, right, which means all real numbers less than or equal to, now we have that little line there, equal to 1/2, right? So now we go to 1/2. So this is a little bit different because we were just doing all of our number lines by ones here. So now this number line is actually in half, right? So 1/2, a half, 1. This is 0, -1/2, -1, -1.5, -2. So when you separate it like that and you make it kind of like in increments of half, it makes it easier to graph when you're talking about halves. So this is x is less than or equal to 1/2. So that means right at 1/2, that's where we're going to make our circle. And since it's less than or equal to, we use kind of like the upset emoji, which means that the circle is closed in. And this means that it is equal to, which means it includes 1/2. So whenever you see that closed in circle, that means that 1/2 is a solution. Versus right here, the open, -1 is not a solution. 5 with that open circle, 5 is not a solution. Okay, but when it's closed like that, that means that 1/2 is a solution, and really everything less. So everything this way would also be a solution. So 1/2's a solution, 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 not a solution, not a solution, not a solution. Anything over here would not be a solution to this inequality. Okay, so this last one right here, okay, what color have I not used with my highlighters? Pink. Okay, we have this inequality, and this states all real numbers, that's x, right? All real numbers greater than or equal to 0. And that's how you say it. All real numbers greater than or equal to 0. It's really important that you know, like, how to, like, communicate. So I just really want you to pay attention to the wording here, and I want you to stretch yourself to use that wording, okay? Because the more you use it, the more you understand it, the more then when you read it or you see it, then it just makes sense, okay? So just really practice on using this stuff. So here, everything greater than or equal to 0. So we're going to have a number line. This one is in units of 1 instead of the half up here. And so we're going to go to 0. Right, and it includes 0, so since it includes, it's greater than or equal to, we're going to use this closed circle, and so I'm just going to make that bigger here, right on 0. So whatever this is, that's, whatever number is there, that's where the circle goes, okay? So open, open, close, closed. And x is bigger than 0, so it's all the numbers that are bigger than 0. So solution, 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 solution. What about this one? Yes, it's closed, so that means it's a solution. And then anything over here, not a solution, not a solution. Okay, perfect. So that's pretty much graphing. Let's look at some different examples on how to graph. So here we go. Example 2. Let's do this. So it says, example 2 is graphing inequalities, so we're just supposed to graph each inequality. So we have some wonderful, like a number line already here, which is really nice. And so we have, this would be all real numbers greater than or equal to 3/4. So since we have a fraction, these are actually in 3/4. So this is 0, right? This is 3/4, and then this is 1 3/4. That 1 is kind of wimpy. No, this doesn't say that. That's 1 1/2. But that's what 3/4 plus 3/4 is 1 1/2. And then if you add 3/4 to 1/2, you get 2 1/4. And then if you add 3/4 to 2 1/4, you get 3. And then if you add 3/4 to 3, you get 3 3/4. I just feel like these numbers are so small, so I just want to make them a little bit bigger. And then if we go this way, we're going in increments of 3/4, so this one would be negative 3/4, okay? So I just wanted to make that a little better. So m is greater than or equal to 3/4, so I'm going to go right to 3/4, right, which is right here. And then am I going to do an open circle or a closed circle? And we use a closed circle, all right? So that means that it includes 3/4. So I'm going to include 3/4, and then it's everything bigger than, right? So the alligator's eating the bigger meal, which means m is bigger. All real numbers are bigger. And all the numbers that are bigger than 3/4 are all this way. So that's pretty much it. So this is a solution, 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 solution. Anything over here, not a solution, not a solution, not a solution. All right, you got it? So that's how you graph it. Let's look at this next one, B. So it's not as simple as this. We have t solved by itself, which is wonderful. But over here, there's a little bit of funny business going on. So we're going to actually have to simplify this first. No problem, we can do that. It's just order of operations, right? So we do parentheses first. I'm just going to rewrite this. So t is less than 5, and then negative 1 plus 3 is 2. And then 5 times 2 is 10. So I'm just going to write t is less than 10, okay? So it looks like, here's my 0. It looks on this graph that everything's in increments of 2. So then I just go and find 10. And this is going to be an open circle, right? Because it doesn't include 10. And then the answers are everything less than 10. So it's going to be everything this way. And that's how you graph it. So these graphs are already here for us, but on your homework, I mean, literally you just have to go here and you can make a 0, and then you can make it in increments of 1 or 2 or 1/2 or 3/4 or whatever is needed for the problem. You just make little hash marks like this, and then, you know, if I made it in ones, then I would just, you know, label them like so, right? So you can do something like that. In the past, like if I was actually doing this and I didn't have a graph that was already made for me, I might just do this, really. Make a line, make 0, make 10, put an open circle, and just say, hey, t is less than 10, okay? So I don't want you spending an hour making the perfect number line. I mean, you could always put like maybe 5, maybe do it in increments of 5 and then 15 or something like that. But literally, you don't have to spend an hour making the perfect number line of all time. It can be kind of simple, because what I want to know is, I want to know, do you know it's an open circle? Do you know it's a closed circle? And do you know that it's the solutions on the left or on the right? Okay. So now we're going to move on to check it out, example 2, and I really feel like you're ready to try these on your own. So I want you to complete A, B, and C on your own. Go ahead and graph them. When you get done, oh, wait, here's my friend, the pause dragon. Remind you to this, it's time to pause your device, work out A, B, and C, and then when you get done, press play, and we will go over your solutions. All right, see you in a bit. All right, let's see how you did. So this first one, C is greater than 2.5. We're going to graph it. So we're going to find 2.5. So this is in ones, but that's no problem. I know that 2.5 is halfway between 2 and 3. So I'm just going to make a little hash mark. Maybe I'll make it a little bigger just because, and just call that 2.5. Make it a little bigger. Okay, that's 2.5. And then it's basically, this is going to be an open circle, right? Because it doesn't include 2.5, and C is greater. So that means everything over here is solution. So solution, wait, this is not a solution. So 2.5 is not a solution, but solution, 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 not a solution, all over there. All right, perfect. Let's go to B. So B is one of those ones we have to do a little bit of work. So W is already isolated by itself right here. But we have to kind of simplify this. So 2 squared is the same thing as 2 times 2, okay? If you had 2 cubed, that is the same thing as 2 times 2 times 2. If you had 4 cubed, that would be the same thing as 4 times 4 times 4. So this number on top just means that you multiply whatever this base number is. This is called an exponent. This is the base. And you multiply that base by itself 3 times. So 4 times 4 times 4. You multiply this base by itself 3 times, 2 times 2 times 2. If it was something like 2 to the 5th, then you'd multiply this base by itself 5 times. So 2 times 2 times 2 times 2 times 2. Okay, that's like a little cliff notes on exponents. So 2 squared means we multiply this base by itself 2 times. So that's just 2 times 2, which is 4. So we have 4 minus 4, and then 4 minus 4 is 0. And then the big thing with inequalities, and I don't know if you did this or not, but you need to make sure that that inequality is on the left side. So right now it's on the right side, so I'm just going to go up here because I don't want to run into my, I'm kind of tight on space. And so it really needs to be, the W, the variable, needs to be on the left, and the number needs to be on the right like that. And so when you do that and you swap the variable with the number, you just need to make sure that this sign is right. And I'm telling you, I just really like to think about the alligator. Okay, so the alligator is eating the bigger thing. In this one, inequality, the bigger thing is the 0. So that means when I rewrite this and I swap the W with the 0, the alligator has to continue to eat the same thing, right? So right here, it's eating the 0. That means right here, it also has to eat the 0. So at the end of the day, we have W is less than or equal to 0. So we go here to our number line. It is equals 0, so that means it's going to be a closed-in circle, and the solutions are everything less than or equal to 0, which would be all the numbers this way. So that's our answer, including 0. 0 can be a solution too, but everything over here is a solution, everything over there is not a solution. Okay, so if you got that right, awesome job. If you didn't write it and solve it the way I did, I need you to erase, and I need yours to look exactly like I did, especially with that variable being on the left side and making sure that your signs are positioned correctly, or your inequality signs are positioned correctly. Okay, perfect. Okay, so let's move on to C. C is m is less than or equal to -3. Okay, so this one's kind of tricky because we have 0 here, but it's like 2, 4, 6, 8, 10, 12. And then -2, -4, -6, -8. So we really need to find that -3. We know that it is halfway between 2 and 4, right? And these just are shifted. Like this -4, I don't know what happened, but it's supposed to be right here. And this -2 is supposed to be right there. So just, make that adjustment. So yeah, so that means that -3 is going to be right here. I'm going to make it big and long and just write -3. And then we're going to, is it going to be open circle or closed circle? Well, it's m is less than or equal to, so it can equal -3, so that means that it's going to be closed. That closed represents that it can equal. And then it's everything less, and all the numbers that are less than -3 are this way. So there's all the solutions. So if you got all those right, awesome job. And if you didn't, make sure you make the adjustments on your notes, and your notes look exactly like mine do. So, all right, that's it. We'll see you in a little bit for example 3.